Assalamualaikum and hi! We are students from AS1204M want to present a video presentation for Madam Hasni binti Lauding about radio wave heating. Introduce ourselves before starting the video presentation. Hi, my name is Raudatu Shakira binti Muhammad Sahabuddin and my student ID is 2023-864658.
Hi and Assalamualaikum. My name is Nur Amni Shamimi binti Arif. My student ID is 2023-665-024.
Hi and Assalamualaikum. My name is Muhammad Akif Anaki bin Muhammad Farid and my student ID is 2023-X03902.
Assalamualaikum. My name is Muhammad Mustaqim bin Muhammad Sauli. My student ID is 2023-617-476.
Hi, my name is Muhammad Haziq Zikri bin Baharuddin and my student ID is 202-3677358.
This is the content for our video presentation.
So today I'm going to talk about something interesting that called radio wave heating. Most of us know that radio wave are used for things like listening to the radio or using Wi-Fi. But did you know that radio wave can also be used to heat things up? So in this video, I will explain what is radio wave heating and what the main type of radio wave heating. So, what is radio wave heating? Radio wave heating is the process that uses radio frequency or known as RF wave to heat material. This technique is commonly applied in various industries, including medical treatment, food process, and material engineering. The RF causes molecule particle, water molecule to vibrate, generate heat from within the material rather than relying on external heat source. There are two main types of radio wave heating. The first one is induction heating, and the second one is dielectric heating. So I will go first about induction heating. Induction heating is when a magnet or electric field causes a current voltage in something without touching it. So you can imagine when you bring a magnet close to a coil of wire, even if they don't touch each other, the moving magnet can create electricity. The induction is usually used in metal processing or industrial heating. So the second one is dielectric heating. Dielectric heating is a material that doesn't conduct electricity but can store electric energy in electric field. It is used in application, plastic industry, and food processing.
Hello everyone, today I'm going to talk about radio wave heating, a method that uses radio waves to generate heat inside materials. It's a fascinating technique widely used in industries and even medicine. So let's explore how it works. Radio wave heating works by using electromagnetic waves, specifically radio waves, which are in the low frequency part of the electromagnetic spectrum. These waves are able to penetrate into materials and produce heat. This technique is especially useful for materials called dielectrics, which we talk more about in the next slide. Let's begin with how radio wave heating starts. First is radio wave generation. A radio frequency generator or RF generator produces electromagnetic waves in the frequency range of 1 to 300 MHz. So why is this range? It is because this frequency is just right, high enough to excite molecular motion but low enough to penetrate deep into materials. Next, we have what happens when the radio waves reach the material. The object to be heated, like plastic, wood, or even human tissues, is placed either between electrodes or inside a coil that emits the RF waves. What's interesting here is that, unlike surface heating methods like an iron, these waves actually penetrate deep into the material. This allows the heat to start from the core and spread outward. For example, it's used to dry stick wooden panels or in medicine to heat beneath the skin without cutting it. So, how does the energy turn into heat? Well, most dielectric materials like water, food or plastic contain polar molecules. These have a positive and a negative side. When the RF electric field rapidly switches the direction, minutes of time per second, these molecules try to rotate and keep up. This constant back and forth motion is called dielectric heating. Now for the final step, how the heat is actually produced. As these polar molecules rotate and move around to follow the field, they bump into each other. This causes internal friction, and that friction becomes thermal energy. In other words, heat. What makes this better than traditional heating? There are no hot surfaces required, the heating is faster and is more uniform, especially in thick or hard to heat materials.
Okay, so here I will explain how actually a microwave oven will work. Okay, so first, the function of the transformer in the microwave is used to convert the standard household electricity to power the magnetron. Okay, so it will generate the microwave from the electricity. So second, the voltage will hit a filament at the center of the magnetron that will bounce off the electron, and the electron are wheeled around by the two rings of magnet in the microwave. Third, the microwave are transmitted into the cooking chamber by an antenna inside the microwave oven. And fourth, the microwave are bounced around the cooking compartment eventually to penetrate the food and in turn to heating it up. The microwave straw also contains a metal mesh with a small enough of hole that can make sure the microwave can escape, but the visible light can, so we can see what is cooking inside. Lastly, the microwave also have a revolving glass turntable that moves like a carousel, and it will heat the food evenly. However, we know that microwave oven have its own safety consideration, disadvantage and advantage. So what is the safety consideration for using the microwave oven? So first, we need to know that microwave oven cannot put any metal item inside the microwave, and we can only use the suitable ceramic, plastic and glass dishes to avoid some melting. And lastly, we need to open the seal container before putting it inside the microwave ovens. Okay, so what is the disadvantage and advantage of using the microwave oven? So the disadvantage of using the microwave oven is it will damage your eyes because of the light, and it will burn your skin because it is so hot, and the food you put inside the microwave will have some poison maybe. And fourth, no deep frying inside the microwave. And so what is the advantage of using the microwave oven? First, it is safe to use and preserve some nutrient, and also it is easy and quick to reheating, easy cleaning, and also it will make you cook with confidence, easy to clean and energy conversion.
So, I want to explain about RF welding. What is RF welding? RF welding, also known as high frequency welding or dielectric welding. The frequency range is 2732 MHz and 40,063 MHz. And for the benefit, it has 4 benefits. First, fast process. Second, does not involve hazardous solvent. Third, provide air and liquid tight seal. And lastly, provide a much stronger seam or bond. For the type of thermoplastic to be welded, first, polyvinyl chloride, which is PVC. And second, nylon. Third, polyethylene terephthalate, which is PET. Fourth, ethylene vinyl acetate, which is EVA. And lastly, polyolefin. And for the application for RF welding is sealing thin sheet of polar thermoplastic. And lastly, for this slide, example of product. It has 3 examples. First, blood bags. 2, disposable clothing. And lastly, blood pressure cuff.
Assalamualaikum warahmatullahi wabarakatuh. I want to talk about medical diathermy. Let's start with the definition. Medical diathermy, specifically radio frequency diathermy, is a treatment that uses high frequency electromagnetic wave to generate heat deep within the tissue of the body. This heat isn't just surface level, it penetrates into the muscle and joints, helping to relieve pain, improve blood flow, and support faster healing. It is especially used for treating chronic condition and injury. Now, let's move on the benefit. One of the main benefits of diathermy is that relief muscle and joint pain. That deep helps relax tight or sore muscle and can reduce stiffness in joint. Another important benefit is improved blood circulation. When blood flow increase, more oxygen and nutrients are delivered to injured area, which help tissue heal faster and reduce recovery time. Let's look at the application. Diathermy is commonly used to treat soft tissue injured such as sprain, muscle strain, and tendon. It's also helpful in reducing inflammation and swelling, which are commonly symptoms after injury. By decreasing swelling, it can also help patients regain their range of motion more quickly. This makes it valuable treatment in sport injury, recovery, and post-surgical rehabilitation. Lastly, safety is very important when using diathermy. Before starting the treatment, all metal objects such as jewelry, bags, and any accessory must be removed. Metal can heat up during the season, which can cause burn or discomfort. In addition, diathermy should never be used on open wound or infected skin because it could worsen the condition and slow down the healing process.
In conclusion, radio wave heating stands out as the highly effective method of energy transfer using electromagnetic wave. Especially within the radio frequency range, what makes it truly valuable is its ability to deliver rapid, uniform and non-contact heating, a quality that sets it apart from traditional methods. This technology plays a critical role not only in industrial processing but also in medical treatment like diathermy, and even in advanced scientific fields such as plasma heating, for fusion research, a potential future source of clean energy. As we have seen, its versatility and efficiency make a radio wave heating not just in modern innovation, but a powerful tool with a wide-reaching impact across multiple disciplines. In conclusion, radio wave heating stands out as a highly effective method of energy transfer using electromagnetic wave. Especially within the radio frequency range, what makes it truly valuable is its ability to deliver rapid, uniform and non-contact heating, a quality that sets it apart from traditional methods. This technology plays a critical role not only in industrial processing.
So lastly, this is our reference during researching the information for the video presentation. That's all from us. Thank you Madam Hasni binti Loding for listening our video presentation.